So, my name is Amit, and I have been taking these webinars for Skill Upright for quite some time now. I've been in the industry for 18 years, right? And I'm based out of Bangalore, which is in southern part of India. And yeah, my experience has been mostly on DevOps and cloud, and everything that you can do with DevOps and cloud. So CI/CD, infrastructure management at a scale, um, services management, deployments, yeah, everything that comes under the purview of DevOps is being done by me. Okay. Why are we here today? So we are here today to talk about AWS, right? And I'm going to talk about AWS, and I'll give a brief demo on you know on EC2. Little bit insights on EC2 along with introduction to AWS. Okay, that's the agenda. At the end of 1 hour, you should know what is AWS and you should know how to spin up a virtual machine or an EC2 instance for your own personal use at least. All right. So what is AWS? Before we understand AWS, let's understand what is cloud, right? How many of you do not know what is cloud? Everybody knows, right? Oh, okay, one person does not know. Anybody else? All right. So let me give you a brief. Let's talk about what is a local data center, right? What is local data center? Let's say you are working in an organization, right? There is a team of people and they need computers. They need compute power, right? To do any kind of work, to write programs, to compile, to generate reports, to generate models, to analyze, whatever you do in this world, you need compute power, right? How do these people get the compute power? Of course, they have their own laptops and maybe desktops, but that has very limited computational power. It lacks the computational power that is required for resource-intensive jobs. Also, if this person has a computer or a laptop, they can't share the resources or the compute power of their laptop with others. So how do you get the compute power? You rely on a lab, right? Or a data center where there are lot of computers, um, lot of computers arranged nicely for our own for teams utilization. So anybody can log in or can connect to these computers and then perform their tasks, right? Write code, do compilation and things like that. Now this is made available using local data center. That means there is a separate facility, it's a separate building maybe, which has separate cooling, power, and manpower for managing all these compute resources, right? So it's not just servers, it's storage devices which are mounted into these machines. It's networks, right, which make it connected to external world or internally. So all these physical infrastructure is called a local data center, which is used by your team, right? Now, uh, it's pretty important. Data centers are pretty important for an organization, but they're also very expensive to manage. So you need to buy these servers, spend some money to buy these servers, then spend money on cooling, spend money on power supply, and spend a lot of money in training people to manage this infrastructure, right? And then for upkeep, of the data center, you have to spend more money. For example, this server is outdated or end of life, then you buy a new server to replace this one. So this one is gone, but you have to shell out a lot of money to get the new server. And if you have to add more resources, if the team increases, they want more computers, they want more storage, then you end up spending more money to, scale out your infrastructure, right? So this is a local data center. Now, contrary to that, we have cloud, um, let's say cloud data centers. Well, I should not call it data center, but just to give you an analogy, local data center, cloud data center, right? Or I could just say cloud, right? What do we have? Let's say you have an organization and you again are a team of people working on some project. You need compute power. Instead of setting up your own data center, what you do is you talk to AWS or Google Cloud or Azure, whatever. Let's take an example of AWS. You talk to AWS and you say, hey, we need, let's say, 20 servers. And we need 20 servers. 10 of them should have 4 CPU and 16 GB of RAM, and 5 of them should have 8 CPUs and 256 GB of RAM. And let's say 5 should have 64 CPU and 1 TB of RAM and maybe some GPUs as well, right? So you can talk to AWS and get these servers, right? You don't have to set up your own data center. You don't have to hire people. You don't have to manage the power or cooling. Everything can be done by yourself. You don't even need to talk to anybody from AWS. You can log into AWS, give them a credit card, and go ahead and create your services, right? You can say, hey, I want 2 new servers today, and then use them and then destroy them as well. So you can create the servers on the fly. You can create the resources on the fly. The management of these resources, the servers, the operating system, the architecture, everything is done by the AWS team in the backend. Okay, so this is what cloud is. Now, AWS is the most popular cloud, and I think AWS uh, is being closely followed by Azure and then by GCP. These are the 3 main players on cloud offerings. And let's talk a little bit about what offerings or what kind of resources are offered by cloud. So let's open this diagram. Okay, this is quite. Yeah, no, not this one. Let's see. Okay, so you see this diagram, right? Just give me a second. All right. So let's say you set up your own data center, right? This is your own data center, on-premise data center. You need to set up your own networking. You need to set up your own storage devices. You need to set up your own servers. Then you need to set up your own virtualization. Then you need to install operating systems on virtual machines. And then your team has to manage the middleware, the runtimes, the application, and its associated data, right? Everything is your organization's responsibility, right? But if you go to cloud, then there are some aspects of the operations that you can offload to the cloud provider. For example, you can choose to let the cloud provider manage all these things, right? You can say, hey, AWS, you take care of networking, you take care of storage and servers and virtualization. I am going to get a virtual machine and then install the OS, install the middleware, runtime, my application, and data. So this, the green ones, the blue boxes becomes my responsibility. The orange boxes are AWS's responsibility. So if you want to take the responsibility of operating system and above, then it's called as infrastructure as service. AWS is providing you the infrastructure as a service. Anything on top of the infrastructure is your responsibility. There are some resources or some compute power which can be obtained as platform as a service, right? So AWS is going to manage everything up to the runtime, and you just have to manage your application and data. For example, if you write an application in Java, then you can just ask AWS to give you a way to deploy your Java application, and you manage the application and data, but you don't care on what server it is running or what operating system it is running. It's just offloaded for AWS to manage, right? Such a service is called platform as a service. So you just manage your application and data. You don't worry about underlying hardware or software. Then finally comes the software as a service. So you don't even manage anything. You just manage your data a little bit, but everything else is managed by the cloud provider. For example, your, let's say, Adobe Creative Cloud, right? Or your Google Drive. So Google Drive is also a cloud storage option. You don't have to worry about where Google Drive is running, what are the servers and all that. You just have to worry about what data goes into Google Drive and how you can manage it, you can delete it, you can share it. That's all. Right? So that becomes a software as a service. So these facilities are provided by cloud provider. Right? So hopefully it makes sense. Now, let's talk about what are the various services provided by AWS. So if I create an account on AWS, right, I can log in, and this is called the AWS console, especially web console, right? If you go to aws.amazon.com, this is the homepage of AWS, and you can read about everything about AWS here. I'm not going to go through that, but all the major services are here. So you can see, explore the products. You have all the products here. You can create an account and then sign into the account. You need to provide a credit card because they will charge you for the resources that you use, but they will not charge you unnecessarily, right? So it's safe to give your credit card information. When you create an account, you can use many services for free for 1 year in AWS. So their virtual machines, storage, you can use up to a threshold. You can use them for 1 year for free. Okay. But if you exceed the threshold values of the free usage per month, then you have to pay. Otherwise, if you are within the limits, you don't need to pay anything. All right, so this is AWS, and when you log into AWS console, you see like this, right? You can click on services, and these are all the services that you can create and use for your development, right? So there are services for analytics, there are services for blockchain, there are services for database, there are services for, let's say, there should be something called AI or something somewhere, maybe machine learning is there, right? So there are a lot of services, right? End user computing for, uh, desktops and things like that. Then there are the most popular services are compute services. So compute services are services which give you raw compute resources, storage, virtual machines, functions, and things like that. Right? Now, there are many AWS services, and maybe one day when we have some time, we are going to go through some of the other most popular services. Today, I'm going to talk about EC2. Okay. If I go to AWS homepage, I can go to Amazon EC2 here. I can read more about it. So EC2 stands for Elastic Compute Cloud, right? That's why EC2, because there are two C's here. So EC2, Elastic Compute Cloud. And you can create the servers. These are nothing but virtual machines. EC2 is a fancy name for a virtual machine. And you can create any kind of virtual machines depending on your requirement. Right? Now, when you create a virtual machine, what are the specifics that you need to know before you create a virtual machine? You need to know how many CPUs you want. You need to know how much RAM you want. You need to know how much data disk you want to have. And you need to know how many operating or which operating system you want, right? These four things are required to create your virtual machine, right? So a virtual machine with 4 CPU, 16 GB of RAM, 100 GB of hard disk, and Ubuntu operating system. When you get that, you can manage your own application on top of it, right? So an EC2 instance is a infrastructure as a service because they are going to give you everything up to operating system, and then it is your responsibility for managing the operating system, installing updates, then managing the middleware, runtime, application, and the data, right? So now, when you create an EC2 instance, how do you choose your the compute power, how many CPU or how many RAM? So when you create an EC2 instance, you can't specify that, hey, I want 1 CPU and 2 GB RAM, right? It's not like that. There are some predefined configurations. And I'm sure one of the configuration will meet your criteria because there are many of them. So if you see the instance types, right? Instance type is nothing but the configuration of a virtual machine of an EC2 instance, right? For example, the highest tier is M7G. M7G is the configuration type. And if you choose, for example, M7G large, right? You can see there is 2 CPUs, 2 GB of RAM, and 12.5 Gbps network, right? But it is powered by Graviton 3 processors. It has DDR5 memory and things like that. You can have up to 64 gigs of RAM, 64 CPUs, 256 gigs of RAM, and 30 Gbps data transfer, right? You can also choose, for example, M7i, right? It has Intel Xeon-based processors, virtual machines. So you can have 192 CPU cores, 768 GB of RAM, 50 Gbps data transfer, right? There is also accelerated computing, right? So you have, um, there is GPU as well. I'm not sure about the specifications of the GPU, but there is GPU, right? There is high performance computing. So there you can have specific configuration. But let's go for general purpose. That's the configuration that many people use. And the lowest tier is T2, right? So T2 is 3.3 gigahertz Intel Xeon processor. And what you choose is you can start with as small as 1 CPU and 500 MB of RAM, right? This is called T2.nano. So if you tell everyone, hey, I need a EC2 instance with a configuration or instance type T2 Nano, you will get 1 CPU and 0.5 GB of RAM. Network performance is very low and the storage is EBS. Okay, we'll talk about EBS and all later. CPU credits per hour is is the cost in terms of AWS credits, but it's not a very good idea. So I can also show you how much it costs to use, right? But maybe later. So T2, this is T2 Nano, then T2 Micro, 1 CPU and 1 GB of RAM, T2 Small, 1 CPU and 2 GB of RAM, and T2 XL, which is 4 CPU and 16 GB of RAM. Many people prefer this T2 XL because it has moderate network performance as well, right? So this is your instance type. When you create an EC2 instance, you can say, hey, I need this particular instance type. If you want to know how much each instance costs, we can go to pricing, right? And you can see on-demand pricing. And let's see. Yeah, the pricing is here, right? The pricing depends on what sort of operating system you install on the EC2 instance, what sort of, in which region you use, right? So region wise also price differs, not that much, but it does differ between regions. And if you're running it at a scale, then the even 1 cent an hour makes a lot of difference. So let's say I'm running in US East, or let's say in India, for example. So APAC Mumbai, which is also known as AP South 1. So in this region, I'm using Linux instance, and the instance type is, let's say, general purpose. And if I say general purpose, I can see these are the prices, right? If I want to know the prices of T2, I just type T2 here filter, and you can see T2 Nano is 0.0062 USD per hour. So if I create this virtual machine, T2 Nano virtual machine, with a Linux operating system in Asia region, then I have to pay around 6 cents, not even 6 cents, 0.06 cents per hour of the utilization. So as soon as I power on this virtual machine, they will start charging me here at this rate. If I take maybe T2 XL, then I have to pay around 20 cents per hour. 20 cent translates to 16 rupees, 16 Indian rupees per hour of usage. Let's say you have a project and you need a 4 CPU and 16 GB of RAM machine for that. You have a project in your college or a private project, and you need such a machine for, let's say, a month. And every day you want to use that machine for 2 hours. So if you didn't have AWS, you will have to go to the market, buy such a machine with four CPUs and 16 gigs of RAM. That would cost you at least 50K, right? 50K wouldn't get 50,000 rupees wouldn't get you that powerful machine. But yeah, to be on a conservative side, 50,000 rupees you will have to spend to get this machine. And once your work is done, you still have to maintain the machine. It is yours. You have paid the amount fully. And that is a waste. But if you use AWS, you can pay 20 cents an hour, which is like 15 rupees an hour. And if you use for 30 days, 2 hours a day, that means 60 hours. How much you pay? 6 to the 12. You check 120 rupees, maybe at most, right? So that's the advantage of AWS or cloud computing, right? So this is how you can check the pricing. But the pricing will differ. If I change the operating system to, let's say, Windows, right now T2 Nano is 0.0062. If I change it to Windows, it changes to 0.0085, right? So there is like 20% increase. T2 XL is 23 cents, 24 cents now. So it's like 20-30% increase. Because Windows also has to, it's a licensed product. So you also pay for the license here. If you choose an enterprise Windows, for example, Windows SQL, then you may end up paying much more. They don't even have T2 XL is there. So you pay 1.73. Right? So you pay for Windows license and SQL license. So it depends on what kind of um, usage you have. There's the question, what is on demand? On demand is uh, pay by the hour or second. So you pay by the minute of usage. Okay. But if you know that you will use the machine consistently, then you can have spot instances. That means you can create an instance, you cannot power it off. Even if you power it off, then you will be charged. But then you make a commitment and you get a cheaper rate. Okay. All right. So now let's go to our console and let's click on services. And I'm going to click on EC2. And this is the EC2 dashboard, right? I'm going to create an EC2 instance now. So on this EC2 dashboard, I can see I can see my instances, right? So how many instances I have created. I can create new instances. I can delete the instances. Then I can see more information about those instances, which I'm going to explain later. Okay. So let's say I want to create a virtual machine with, let's say, T2 micro. So I'm going to use a wizard, which is launch instance. I click on that, and this gives me a form, right? The first thing is, do I need to give my machine any name? I say, test webinar, for example. So this is the name of my machine. And then I'm asked to choose which operating system I want. I can choose Linux, uh, AWS flavor, Linux, or I can choose Mac OS, or I can choose Ubuntu, or Windows, or Red Hat, or SUSE Linux, or whatever, right? Let's say I choose to go with Ubuntu, right? Then I can choose which release of Ubuntu I want. 2204, 2004 LTS, 20.04 LTS with SQL Server, yeah? And there are many options. Now the thing is, if you already have SQL license, for example, then you don't want to pay for SQL license here again. So you can just get a plain Ubuntu server and then on top of that, install your own SQL server with your own license, right? So I can get these two operating systems for free. I just choose 2204. Then which architecture I want, generally it is x86, but if there are specific use cases, you can also go with ARM, but this is x86. Now, in AWS, these operating systems are called Amazon Machine Image. You see here, Amazon Machine Image. Because it's not the plain operating system like Ubuntu. It is Ubuntu plus a lot of configurations which make it work with AWS, right? So kernel optimizations, it will have AWS specific kernel. It will have a lot of utilities installed to manage, AWS access and permission. So it is an Amazon specific operating system which will work only on AWS, and that's why it is called as Amazon Machine Image. So when you create a EC2 instance, you have to choose an AMI, right? So we chose this AMI, and each AMI has a unique ID. For example, the AMI which we chose, Ubuntu 2204 with the architecture x86 64-bit, has a unique ID, this one. So this unique ID is, for example, CFEC at the end. If I go for 2004, then the unique ID would be different, right? This is a different AMI ID. If I choose any other operating system, the AMI ID will be different, right? So you choose the AMI, then you have to choose instance type, right? By default, it allows me to create one CPU and 1 GB of RAM, which is T2 micro. And since it's a free tier account, I have it free tier eligible. That means I don't have to pay anything for it. But if I choose T2 Nano, then I have to pay this much money, 0.0058 cents, um, 0.0058 USD per hour. Right? So I go with the free one. And then there are two interesting things. First is key pair. How do I log into this machine that I'm going to create? So the login is always via SSH. If you don't know what is SSH, I suggest you go and read about it later after the session. But the SSH allows you to log into a remote machine by use of username and password or by use of a secret key. Okay, AWS does not allow you to log in with the normal username and password with their default AMIs. So you have to use a key. So either you can create a key and keep it in your account, or you can create a new key pair right now. So I create a new key pair and I give it a name, let's say I create a key pair like this, and I click on create key pair. And as soon as I do that, a private key or a secret key will be downloaded on my system. You see here, this PEM, this is a secret key, is downloaded on this system. If I lose this key, then I won't be able to recreate it. So it's very important that we keep it safe. All right, so this is the key which is going to be used for login. I can create more key pairs and I can choose which one I want to use. Okay, right now I just have one, so that's the default. Then is the default network settings. Okay, right now in AWS in my account here, if I create a virtual machine, right now only SSH traffic will be allowed. Right, so the default value is allow SSH traffic from anywhere. But I can say allow SSH, allow HTTPS, allow HTTP, or I can click on edit and I can say allow let's say allow all traffic, right? Allow all traffic to my system. Allow all traffic from anywhere to this virtual machine which I'm going to create, to this EC2 instance. So this is kind of a firewall rule. Okay, and then I can choose how much storage I want to have. So this is the root volume, that means the operating system image. So 8 GB is sometimes enough, but you can increase it. You can use up to 30 GB for free if you have free account for 1 year. So you can use that, or you can have more than that also, but then you have to pay. You can add more disks and they will be mounted in your machine. But let's go with default of 8 GB. And there are some advanced settings, but I don't want to get into those. So to summarize, we chose an AMI of Ubuntu 2204 x86. The virtual server type is T2 Micro, which is 1 CPU and 1 GB of RAM. Security group or the network firewall is, I have defined that any communication should go inside it. And this is the storage, right? So these were the requirements. I have already defined everything. So CPU and RAM is, let's do the CPU and RAM is instance type. Disk is disk. And OS is AMI, right? Cool. And now I can click on launch instance. I can also say how many instances I want. I can say, hey, with this configuration, create 5 instances or 10 instances or 100. Then all those 100 virtual machines will be created for me. Let's say I create 2, right? 2 virtual machines. Click on launch instance and it shows me some progress bar and it says success. Let's not do anything here. Let's go back to EC2. So now this is my EC2 dashboard. And here, if I refresh, you see instances. There are two instances running. I created one key pair, and there are two volumes, which are the nothing but the disks which are mounted in these instances. I click on instances, and I see these are the two instances. One is running, one is pending, so it may take some more time for it to come up. And now it is running, right? When I create an EC2 instance, what do I get? Where I feed this information to an EC2 instance. Right? EC2 instance, what do I get? How do I connect to it? So one is ID. Each instance has an ID. So if you look here, instance ID, which starts with I dash whatever. This is a unique ID for an instance across accounts, across everyone. So this is a unique ID for your virtual machine, right? So you get an ID is equal to I dash X, 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 X. So this is some ID that you get. Then you get an IP address. You get a private IP and private DNS name. And then you get a public IP and public DNS name. What do these mean? The public IP or the public DNS name is something using which anybody from internet, anybody from over the internet can connect to this machine, right? For example, if I go to this instance name, you can see here there is private IP address, and then there is public IP address, then there is public DNS, there is private DNS, right? So if I take this public DNS and if I copy it, and if I open a terminal, now this is my laptop, right? If I do a ping and the public DNS, it will be reachable. So I get a response from it, right? If I copy the IP address, if I do a ping, I get a response, right? So this public DNS and public IP address allow you or allow this machine to be accessible from over the internet. So this is the, let's say this is the boundary of AWS. So from outside AWS, anybody can access it. Then there is private IP and private DNS. So this is reachable from within AWS. So if there is someone or some machine, within AWS, not internet, within AWS, then they can reach using the private IP. Okay, so if I go to my instance and if I copy the private IP address, and from my laptop, if I ping the private IP address, it won't work. Because this IP address is private to AWS. It's private to AWS. Okay, makes sense? Cool. So now we get IP address and the instance ID, and then we can get many other details, right? So I don't want to get into details, but in the networking, you get the subnet ID and all that, which subnetted, what is the network interface and things like that. So that is all for some other discussion, but yeah. Now, how do you connect to it? How you connect to this instance using the private public IP or the public DNS. So when I connect to it, I can simply say SSH and let me use the public IP address or public DNS name, which is this. I can say SSH to this machine. I press enter. It says, do you trust this machine? My laptop is asking me this question. Do you trust this machine? I can say yes. But it will be unsuccessful. It does not ask me username password for that machine. It just simply says permission denied public key. Yeah. Remember, I told you that you have to log into this machine using the private key here. This is the private key that is downloaded. So I can say, well, SSH to this machine, but use the private key from my downloads directory and this one. So this is the PEM file, which is maybe I'll zoom in a bit. Yeah, maybe this one is more visible. So SSH, use this private key, which is the one which was downloaded, which I created, and connect to this machine. Now, any machine that you create using Ubuntu, you should connect as a user Ubuntu. So you can say Ubuntu at. So use this username and this private key and connect to this machine. And now I'm connected. Right? I'm connected now to this machine. And this is the operating system. I can become root. And now I'm root on this EC2 instance. I can do whatever I want. Because it is Ubuntu, I can use apt, and then I can do anything. Maybe I can install Ansible on it. I can install Docker on it. I can install Jenkins on it. I can do whatever I want. Like apt install. So I can just say apt install Docker, and it's going to install Docker for me. And now I can use this machine as my Docker system and yeah, have fun with it. Right? This is my machine now. Once my work is done, I can simply choose uh, this instance and I can go to instance state here. You see instance state. And I can say stop instance. Stop instance is equal to powering down the instance. I stop instance. So what does it say? After you stop the instance, you are no longer charged usage fees for it. That means what we saw, the 16 cents or 0.006 cents, whatever, those are not charged. But I will be charged if there was any disk associated with it because disk is still mounted in the virtual machine. So if there is any disk, then I will have to pay for that. So it just cautions me here that, okay, you will not pay for virtual machine after you stop it, but you will have to pay for disk. And when I stop this instance, and when I start the instance again, the IP is going to change. So the same public IP, which is here, which I used to connect to this machine, it will change, right? After a restart or shutdown or power up of the machine. If you want to get static IP address, you can choose something called as elastic IP and you have to pay for that as well. So those also will be continued to charged. I'm not going to cover in detail about elastic IP and EBS right now because we don't have much time, but this is just for information. So I click on stop and you see this machine is being stopped. If I go here, you will also see the connection is closed. That means the machine is gone now, right? But the other machine is still running. The other machine is still running. And if you want to connect to a machine, I showed you how do you connect. Yeah, you connect via SSH and all that. You can also click on this connect button and you can use an SSH client to connect. This is what I showed you, SSH-I, your private key Ubuntu at the public DNS. Or you can use EC2 Instance Connect, right? Where you can connect via web UI. So you can get a connection here. Now, the problem with this web UI is the interface is not up to the mark. So, you lose connection sometimes, or if you run some scripts, they can time out or things like that. So if you just want to do some quick activity on your system, this is the best. You can just connect to it remotely and then perform uh, your tasks, something like this. But if you don't want to, or if you want a persistent and good terminal, then you always need to connect via SSH with your system's terminal. All right. Once you're done with your systems, you should always delete them. Right. So we powered them down, but once we are done with them and we don't want to use them anymore in the future, we don't care about the data that was created in the machines. If we are certain about that, then you can say instance state and terminate instance. Terminate means delete. It's not just stop, it is delete. And you can delete running instances or stopped instances, any sort of instances. So I click on terminate and you can see it is now shutting down, and then after a while it will be terminated. Okay. So this is what I wanted to show you. In this terminal also you can see instance types. Just give me a second. Sorry about that. So you can see instance types and you can see their pricing and all that stuff. You can also, for example, see the AMIs, right? So what are the AMIs available to you? If you create custom AMIs, you can see here, or if you want to use the third-party AMIs provided by AWS and all, you can see them here. Then you have the backend storage, which is the EBS storage, which is the native storage to create your disks. So any storage that you create will be in the volume section. While creating an EC2 instance, it will create a volume for you, or you can create manually and mount it manually on the EC2 instances. The network side of EC2, you can manage here, like security groups, where to define what kind of communications, the firewalls that needs to be created, static IPs, or also known as elastic IPs. If you want to have static IPs for the systems, you can create them here. Right? Key pairs. Any key pairs that you create will be stored here. So you remember this was the key pair that we created. So you can have it here. If you want to have load balancing in front of your systems, you can create load balancers or auto scaling. So if you want to scale up or scale down a group of systems, you can do that as well. Right? So this is what EC2 is. And yeah, that's all I wanted to talk to you about. And yeah, you will get a recording of this session. Right? You will get recording of this session. And yeah, that's it. So EC2, AWS, I just wanted to give you a brief introduction on these two things. In the next upcoming sessions, we can take up a deep dive into various EC2 topics, or we can talk about storage or any other AWS services. So as and when I get some insights on what you guys want via Scale Up Right, I will do that. Okay. There will be subsequent webinars. So every month there are a couple of webinars. So yeah. All right. Okay. All right then. Thank you everyone. Thanks for joining in. and I'll see you next time. You will get the recording of this session. Bye.